Hey Eli, how are you this morning?
Good. How are you?
Good. Hey Kennedy, good morning.
Good morning.
I was going to go over the number 16, 17, and 18 from yesterday's worksheet on Math Lab and then start on the exam review unless there's something else that you all would like me to do.
Okay.
Is that good?
Mm-hmm.
Okay. Um, good morning, Samantha. I was going to do number 16, 17, and 18 on yesterday's worksheet from class, and then start on the exam review unless you have another question specifically.
No, that sounds good.
Okay.
Thank you.
Uh-huh. Okay, typically what I do when dealing with the quadratic formula is I always identify A, B, and C first. That way, when I'm plugging in, I can be sure of my numbers because really the quadratic formula has a lot of, turns and twists to it, I guess. But once you get everything plugged in, it's just a matter of math from there. So A on this particular one is -1, B is -3, and C is +9. So I'll be plugging that into X equals then the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So then that would be the opposite of -3 is +3. And then we've got 9. And then this is -4 times -1, which is a +4. +4 times 9 is 36. All over a -2. Then X equals 3 plus or minus, and then 9 plus 36 is 45, all over -2. The square root of 45, once factored, is going to be 3 times root 5. What that looks like is I factor 45 into 9 times 5, and then if I put that underneath the radical, I look at the square root of 9 and the square root of 5. Well, 5 isn't a perfect square, so it stays under the radical, stays in jail. 9 is a perfect square. Or even if I did it like this, 3 times 3 times 5, remember pairs make squares, so then that would come out. But either way you look at it, you get 3 times root 5. And then all of that is over 2. So it's 3 plus or minus 3 root 5 all over 2. You could also write it like this. 3 over 2 plus or minus 3 root 5 over 2. Either way is perfectly fine. I think I left off a negative though. The negative here, and I know on the answer sheet, she put it up here. You may leave it here or you may put it here. It doesn't really matter, top or bottom, because a negative divided by a positive is a negative, or a positive divided by a negative is a negative. So either way you look at it, just needs to go somewhere. Some mathematicians even write it well out front, like instead of putting it right here, they would put it out here in front, like in front of the whole fraction bar, if you will. Okay, any questions about that? All right, for number 17, A equals -1, B equals 4, and oh, this wasn't in standard form, so I have to subtract 9 from both sides. So then I have -x squared plus 4x minus 9 equals 0. And then C is -9. So now I have x equals the opposite of 4, or -4, plus or minus square root of b squared minus 4 times -1 times -9. All over 2 times -1. So basically, my first step is always making sure it's in standard form. That's the first step. So I want my whole trinomial on the left and set equal to 0. So it's in standard form. Second step is to identify A, B, and C. And then the third step is to plug in to the quadratic formula all of my values that I identified in step 2. And from here, just work on the math. So the opposite of +4 is -4. And then 4 squared is 16. Then -4 times -1 is -4. And +4, my bad. +4 times -9 is -36, all over -2. So then 16 minus 36 is -20. So I have -4 plus or minus the square root of -20 all over -2. Sorry how low that is. But I've got a negative in that radical. Negative in the radical is a no-no for Algebra 1. So x equals no solution. Or this. Either way you want to write it. All righty, number 18. Not in standard form. So I'm going to subtract x. So 3x squared minus 10x equals -5. Add 5 to both sides. Oops. (3x squared minus 10x plus 5 equals 0. Identify A, B, and C. So A is 3. B is -10. Barely tell that's a negative. My bad. Sorry, guys. And C is 5. So x equals the opposite of -10 plus or minus. Maybe I should clarify this a little. The square root of -10 squared minus 4 times 3 times 5. Ooh, tiny. All over 2 times 3. So x equals 10 plus or minus 100. And then -4 times 3 is 12. And 12 times 5 is 60. So that's minus 60 all over 6. So now we have 10 plus or minus 40 over 6. And then we have x equals 10, and then 40 factored is 4 times 10. So I've got a perfect square of 2 in there. Pairs make squares. 2 root 10 all over 6. So now what I see is that Lord Jesus, please help Miss Sparks. 2 goes into all of these. So I have 10 over 6, which would reduce to, I'm going to erase where I factored. It's going to reduce to 5 over 3. So you could separate it and write 5 over 3 and then plus or minus. But if you didn't, that's fine too. But that 2 is going to cancel here. And then it would be root 10 over 3. So if you separate it, it will look like that. If you didn't separate it, it would look like this. 5 plus or minus root 10 over 3. Either way is perfectly fine. Either way you want to write those is perfectly fine. The key to the quadratic formula is ensuring first and foremost that your equation that you're starting with is in standard form. That's what you want to do first. That's crucial. And because you can't even really identify A, B, and C until it's in standard form. Standard form says you've got 3 terms on the left. There might be a missing term, like B term or whatever would be missing. If the B term is missing and you only have a squared term and a constant, my recommendation would be to do square roots. But with 3 terms, definitely want to put it in standard form. Identify A, B, and C, and then just make sure you're plugging in. And from there, caution, caution, caution. Make sure in algebra, every sign has a number and every number has a sign. So make sure you're watching your signs and that you've moved your signs where they need to go. That's just really the crucial thing about all of that. Making sure you have a right answer. And then the other thing is simplifying radicals. And that would be the other thing outside of just watching the math. Are there any questions about that in particular? And then I'm going to throw this question out there. I was thinking about doing the first 15 problems on the exam review, but I'm going to throw this question out to you guys. Since we're on the quadratic formula and we're kind of in that mode right now, would love you, praying for you on this final.
Thank you.
Good luck. Would you all like me to do the ones that are the quadratic formula on it? Since we're kind of in that mindset, what are y'all's thoughts? Give me some feedback.
That would be nice.
That would be good to kind of stay in that mindset and move on. Okay. All right. I think that's probably a good idea. It just kind of came to me. We'll just give credit to the Holy Spirit, because if it's a good idea, we know it came from the Holy Spirit at this hour of the morning, right? So I think that's toward the back. Guys, oh, there you go. There it is. That's what everybody wants right there. Okay, so 57, 58, and 59 are the quadratic formula ones. And with your permission, as long as this won't confuse anybody, I'm actually going to use this space right here next to 56 as my workspace for each individual problem. Is that all right with everybody? Because I don't think I could get it. Squeeze it in there. Does that make sense? Is that all right with everybody? Is that going to confuse anybody at all?
No, I'm good.
Okay. So, first thing to do. What is the first thing to do? Tell me. Talk to me.
Set it equal to 0.
Set it equal to 0. Good job. So we want to get it in standard form. So my preference is to have everything on the left. So that's just easiest to me. So I'm going to subtract 2a from both sides. Oops, sorry, didn't show it on this side. So that leaves me 3a squared minus 2a equals 10. Now I'm going to subtract 10 from both sides. Got to get it in standard form. So you want to get everything set equal to 0 and all of the terms on one side. So now it's in standard form. That's the very first thing you always want to do. So if you're making yourself notes, I believe that's in our notes. So if you want to just copy that onto a note card and kind of make yourself notes as you're walking through this, because sometimes if you write it, it'll help you. Standard form. Then what's the next step? After we get it in standard form, what do we do next?
Plug it into the quadratic formula. Well, first you identify A, B, and C.
Yes, identify A, B, and C. Good job. So A is what?
3.
Good job. What is B? Oh, look at my stylus. That is scary. A is 3. What is B?
-2.
-2. And what is C?
-10.
Good job. All right, so now plugging it into the quadratic formula. X equals the opposite of B plus or minus the square root of B squared minus 4 times A, which is 3, times C, which is -10. All over 2 times 3. So now, just let's do some math. What is the opposite of -2? +2. Plus or minus. -2 squared is 4. -4 times 3 is -12. And -12 times -10 is 120.
Hey, Miss
All
Fox,
over
I just
6.
joined,
Yes.
and I'm wondering how many problems you've done.
I did 16, 17, and 18 from the worksheet yesterday. And I'm doing, excuse me?
How many from the exam review?
This is the very first one. This is the very first one on the exam. I'm doing all of the ones. We kind of took a poll and we decided that it was best to stick with the quadratic formula this morning and stay focused there. So this is we're going to do 57, 58, and 59 on the exam review to kind of stay in that frame of mind of quadratic. So that's where we are. So this is number 57. All right. So now continuing to simplify, X equals 2 plus or minus 4 plus 120 is 124 all over 6. All right. So the next step is to factor 124. I'm going to try to factor with the factor tree because I know that's what y'all like. So just pray for Miss Sparks. So pairs make squares. What do I have a pair of? Pair of 2's. So that's going to be 2 root 31 because whatever is left, you keep under the radical. If it's a perfect square, it comes out. If it's not a perfect square, it stays in jail, in the radical jail. All right, now we're going to reduce. What number goes into this 2, and this 6? Because remember, you cannot reduce the radical. You cannot reduce that. It's almost like a variable. So 2 goes into 2, 2, and 6. So 2 goes into 2 one time. 2 goes into 2 one time. You can write it. You don't have to. But I'm just showing that we've reduced. And 2 goes into 6 3 times. So we have x equals 1 plus root 31 over 3 and 1 minus root 31 over 3. You can write it like that, or you can write it in fractions. So, but here is your answer, B. And there is the work. I'll leave it there for just a minute before moving on to number 58. Are there any questions about that one?
After we do 58 and 59, could we go and do 56? Maybe.
Yeah. And work
Thank
backwards?
you.
Yeah.
I did
I'm good with that.
54 and 55, but then 56 was confusing.
Okay. I mean, I'm fine with whatever we do. This is y'all's math lab. So I'm fine. It doesn't make any difference to me. So whatever you guys want to do. I'm just here to kind of help. I just felt like it'd be a good idea to stick with the quadratic formula and just keep drilling that home for you guys this morning. All right. Am I good to erase this?
In like 1 minute.
Okay. How are those of you who are on math lab this morning? How are you guys feeling about the quadratic formula? How's everybody doing with it? Because yesterday, I feel like some people were confused. How are we doing?
I'm doing okay. Not great though.
Not good.
Okay. All right. Tell me where the stumbling blocks are for you guys. So I can really, when I'm explaining, I can kind of hone in. Where do you feel like you're getting stuck or you're not feeling real confident about the next step? Where is that?
When the
you're
square
trying to
root's coming.
reduce.
When you're starting to reduce. Is that
Like
what you're saying,
simplify it.
Sophia? And then what did somebody else say?
I said whenever you're trying to simplify it and get the factor tree, like getting the square.
Oh, the
back.
factor tree.
Yep.
Oh, the factor tree. Like what goes in, what stays under the radical and what comes out.
Yep.
Okay. All right. And Sophia, for you, I'm reducing at the very end. Is that correct?
I don't know.
Okay.
It just all gets me.
Okay. I appreciate y'all's honesty. I think if we go through a few and just kind of keep practicing over and over again, hopefully that will help. All right, I'm going to go ahead and start erasing. And once again, just to remind anybody who's just now joining, I am using the area next to 56 in order to do the work for like 57, 58, and 59. Just because there's not a lot of room elsewhere. I probably should have started erasing at the top while y'all were copying at the bottom, because it does take a hot minute to erase this stuff. Okay, I'm going to start asking questions about number 58. Is it in standard form?
No.
No, it is not. So I know that that's going to be the very first thing I'm going to do. Is that confusing to anybody? Does everybody feel pretty good about the fact that you have to get it in standard form first?
Yes.
Yes? Okay. All right. So at least we know we can kind of go from there on that. So this is I'm going to write number 58 up here. Try and give myself a little bit more room. All right, so we start with 4b squared minus 6b equals 70. So in order to get it in standard form, I'm going to subtract 70 from both sides. So I have 4b squared minus 6b minus 70 equals 0. All right, so now the next thing I'm going to do is identify A, B, and C. So what's A?
4.
Good job. What's B?
6. -6.
-6. Good job. What is C?
70.
-70.
-70. Good job. Don't forget those negatives because they will throw you a curveball if you don't, because that's going to change everything. All right. So now we're going to start plugging in. Is this a problem for anybody? Plugging in.
Yeah.
Okay. All right. So we know it is the opposite of B plus or minus the square root of B squared minus 4AC all over 2A. So the opposite of B plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So that's what you want to do there. And my suggestion is don't solve anything while you're trying to plug in. Just plug into the formula as it is. So the opposite of B, so that's going to be minus 6. So the opposite of B is going to be 6 plus or minus. Then -6 squared is 36. Now, you want to look at this second part under the radical. You've got a -4. Remember, every sign has a number and every number has a sign in algebra. So you've got -4 times 4, which is -16. And now, -16 times -70. Oh, that's a big number. Okay, so that's plus 1120. Is that what y'all got? Have y'all done this one yet?
Would you subtract, would it, the 36 be a negative?
No.
Okay.
Wait, what?
Remember, if you're putting this in your calculator, you have to, and you're squaring a negative number, you have to put it in parentheses because a negative times a negative is always a positive. And if I ask you that, you guys wouldn't struggle with that at all. It's just that when you're plugging this stuff in, you're probably punching in -6 squared. So your calculator interprets that as the opposite of 6 squared, or -1 times 6 squared. Does that make sense?
Yeah.
Okay. So you want to make sure that you're plugging it in your it's great to use a calculator, but you want to make sure you're plugging it in correctly. Okay? Just like if you're multiplying this second part, Underneath the radical, I'm just telling you guys, make sure you watch your signs and make sure you use parentheses. There is a lot of room for simple math errors, but underneath that radical, even before you start factoring and all of that, this is where simple math errors can really seriously occur. So you want to, so we've got 36 plus 1120. So we've got 6 plus or minus the square root of 1156 all over 8. So now I'm going to factor 1156. This is a really big number, guys.
1156
So
is a perfect square.
it is.
Yeah.
Oh, praise the Lord. What is it the square root of? Thanks for letting me
34.
know. 44?
34.
34? Who's telling me that?
Samantha.
Samantha. Oh, awesome. Awesome. I appreciate you telling me that. That reminds me of something else to maybe check for. When you're working on this, before you start factoring, like Miss Sparks was just getting ready to do, before you start factoring, do check and see if it's a perfect square first. And if it is, then you don't have to factor and you can kind of do a little jig and say, oh, yes, this is one we don't have to factor. So you would write 6 plus or minus, thank you, Sam, 34 over 8.
You're welcome.
So that might be another good thing to kind of check out. All right, so now 6 plus 34 is 40 over 8. 6 minus 34 is negative 28 over 8. 40 divided by 8 reduces to 5. And this reduces to negative 7 over 2. Which, that's a 2. Which negative 7 over 2 is this guy right here. All right, for those of you who are kind of struggling with the quadratic formula, did you have any experience any light bulb moments at all with that?
A little bit.
Good job. Good job.
After you get the 6
I do
plus
have
or minus 34, do you just add
Say
it?
what now? Right here, I feel like you're asking a question about this part. Remember how there's a plus or minus between the 6 and the 34?
So if it
The
is
first
squared, you
one,
just put that with the square of it?
I'm sorry, say that again.
So you put whatever you get out of what it's squared by, and then add or plus or subtract it by what you've been putting on the outside.
I'm confused.
Yeah. Okay.
Like after the
all-
step, the x equals 6 plus or minus the square root of 36 plus 1,120 over 8. Then I don't know what to do.
Okay, I added 36 plus 1120.
Okay.
And that got me 1156. And I went up here,
Okay.
right there. All right. And then sweet Samantha, as I was getting ready to factor, sweet Samantha reminded me that it's a good idea to check if the number that's underneath the radical is a perfect square before you commence to factoring. So if you put in your calculator 1156 and then did second and square root and you came back with a whole integer, that means it's a perfect square and you don't have to factor. if you put, the number in and it came back as a decimal, then you would have to factor. And that's where you get the radical answers that we've gotten in the past, like we got on number 57. But in this particular case, it indeed was a perfect square. So that square root of 1156 is 34. So the square root of 1,156 is 34. Okay?
Yeah.
So it's not one of those radical answers like we've had. It's a perfect square. So then I've got 6 plus or minus 34 all over 8. Just like in previous answers, I've had a number plus or minus and usually something times a radical over something. But in this case, it's 6 plus or minus 34 over 8. So 6 plus 34 is 40 over 8, which then reduces to 5. 6 minus 34 is negative 28 over 8. And then that reduces to negative 7 over 2, which if I were going to make that a mixed number instead of an improper fraction, it's negative 3.5. So my answer is C.
Okay, but do we have to make it into a mixed number?
On this particular one, on number 58, in order to identify the answer, yes. But if you were just doing something for Miss Sparks and it was a short answer test or quiz, I much prefer improper fractions as opposed to mixed numbers. I'm not a big fan of mixed numbers unless I'm baking and it's asking for 2.5 cups of sugar. Then I'm all about it.
So you first do the addition part of it, and then you subtract it, and then that's what gives you your two answers?
Yes, ma'am.
Okay. Thank you.
Because
so
it's plus or minus. Remember when you take the square roots, it's plus or minus. Because remember, like just something as simple as if I had x squared equals 36, and I took the square root of both sides, I'm looking for all the possibilities that could be the square root of 36. So that would be plus or minus 6. Remember when you identify the square roots? So basically that's this part of the problem. That square root over here is that part of the problem. It's just a little deeper because you're having to use the quadratic formula because it's not quite, because you've got a little bit more in depth of a problem because it's a quadratic and not just a simple quadratic like a perfect square. Does that make sense? That's where the plus and minus comes from. You're looking for all the possibilities. So it's going to be plus or minus something because you're solving for X.
Okay, so if it's not a perfect square and you're factoring, do you take the side with like all the twos on it plus that last number of what you divided by?
The side with all the, I'm sorry?
That probably sounded confusing. Sorry.
The side with all the twos on it. Are you talking about like when I do the birthday cake
Yes.
in class? Yeah, like what you're trying to do is pull out the pairs of all the factors, right?
Mm-hmm.
So, and for each pair, like if I have a pair of twos, I have 1 2 on the outside. For every pair that's on the inside of a radical, I have it, when I pull it out, it becomes 1 on the outside because pairs make squares. So I only identify one pair with a number. So yes, so you would pull that out. Did you already factor 1156? Is that why? Or yeah.
I did.
Or
I was just wondering because been stumped on that before.
You've been stumped on the factoring part?
Yes, ma'am. Of like using what numbers?
If there's two of a kind, that's a perfect square. Because remember, 3 times 3, it makes 9. So 9 is a perfect square. So if I were taking the square root of it, pairs make squares. So, but it would only be like, if I have a 9 inside a radical, it can be written like this, right? So pairs make squares. So a 3 comes out. 3 is the square root of 9, right? So when you're factoring and you have the factor tree and you've got sets of numbers over here, if I had 3 3s, it would be, which would be 27. So if I took the square root of 27, it would be 3 times 3. So there would be 3 3s. So one pair comes out. So that's 3 on the outside, but the other 3 stays on the inside. Does that help at all?
A little bit, yeah.
Okay. I probably should have maybe done a worksheet of simplifying radicals first before I hit this. Just as a review. I know most people have it in pre-algebra. Some do, some don't. So, and everybody comes from a different place, but that's a crucial piece to this, this puzzle here. But maybe we'll have one. Hey, Sam, have you already worked 59? And are you still with us?
Yes, ma'am.
Is she still with us?
Yeah.
Is it factorable?
Let me look. I put it all on like scratch paper. 59. This one was. Yeah, I think so.
Okay, so it is a factorable one. It's not a perfect square.
Wait, hold on. This one was 25. I'm pretty sure.
I'm sorry?
I don't think. Yeah, I'm pretty sure this one's a perfect square.
It's another perfect square?
Because this one was 2025.
Yeah. I think you're right. Oh, shoot. No more perfect squares. No more non-perfect squares to practice on.
There was some on the homework 11 that was like extra.
Okay. Maybe I'll pull that up in just a second. Thank you. All right, so let's do 59. And maybe the lack of perfect squares will help y'all to at least decipher the plugging in and that kind of thing. So 5x squared minus 5x equals 100. So I'm going to subtract 100 from both sides to get it in standard form, because that's the very first step, is getting it in standard form. Everything needs to be on the same side and set equal to 0. So now I'm going to identify A, B, and C. And now I'm going to plug all of that in. So X equals the opposite of B. So the opposite of -5 plus or minus the square root. Remember to put this negative in parentheses, -4 times A times C, all over 2 times A. So X equals the opposite of -5 or -1 times 5. Oops, is positive 5 plus or minus 25. The negative 4 times 5 is a negative 20. And negative 20 times 100, negative 100, is a positive 2,000. All over 10. So x equals 5 plus or minus 20, 25, all over 10. And just like Sam said, this is a perfect square. So 5 plus or minus the square root of 2025 is 25?
It's 45.
45. I was like, that's only 625. 45 over 10. So now 5 plus 45 is 50 over 10, which equals 5. 5 minus 45 is negative 40 over 10, which is negative 4. So 5 and negative 4 are your answers. Or B.
Can you scroll up to the work real quick?
Yes. Did that help at all?
Yes.
Did I circle the right one? I feel like I didn't. Did I? Yeah, I did. I was like, why do I? I'm going to start erasing over here and let y'all have a minute to copy that. And then Grayson a few minutes ago asked for me to do number 56. So I would like to do that because looking at the answer, it looks like I'm going to have to factor that. And once again, simplifying radicals seems to be one of the parts that seems to be one of the sticky pieces of this for you guys for the quadratic formula. And it's basically the same concept when simplifying square roots. So that concept leads itself straight into the quadratic formula. You know, they kind of connect with each other, simplifying what's underneath the radical. All a part of factoring.
I tried to do it, but I think I got some weird decimal or something.
If you're plugging in straight into your calculator instead of simplifying the radical, you would get a decimal. You're supposed to simplify the radical. So that's what we're doing, and it's what you'll do in geometry too. Okay, so number 56. So we've got negative 9n squared equals negative 288. So we're going to divide both sides by negative 9. Because you have to get to simplify for just using square roots, which is the in the instructions here. You have n squared equals 32. Okay? So now, to factor, Maybe this will help, Kennedy. All right, so I'm looking for pairs because pairs make squares. Okay, are you still with me, Kennedy?
Yes, ma'am.
Okay, so I'm taking the square root of both sides. So I've got a pair of 2's, right? So I'm going to write down 1, 2, because that means I can pull one pair of 2's out of the radical. So basically my radical looks like this. If I write all the factors inside the radical that I just factored, this 1, 2, 3, 4, 5 2's. 1, 2, 3, 4, 5 2's. So that's what it looks like. And I'm going to pull squares out. So I've got 1, 2, and I pulled it out. Here's another set of 2's. So I'm going to pull her out. Then I've got this one left. So she stays in. So 2 times 2 is 4. And we did see that over here because the square root of 16 is 4. Root 2. So it's plus or minus 4 times the square root of 2, or a. Got to simplify what's under the radical. Did you get that, Grayson?
I understand part of it, but then near the end I got confused of like where that 4 came from.
Okay. You see this set of 2's underneath the radical.
Yeah.
Okay. What is 2 times 2?
4.
Okay, what's the square root of 4?
2.
Okay, so there's that 2. What's 2 times 2?
4.
And what's the square root of 4?
2.
Okay, so I've got 2 sets of 2 underneath the radical. Pairs make squares. This is underneath a square root. So in order to come out of the square root, I have to have a pair of 2's. So on that outside, every time I pull something out, it has to be multiplied by something else that I pull out. So I've got the other way I could have written this, and maybe you would understand this better, 16 times 2. So what's the square root of 16?
4.
Times root 2. Would that make more sense to you?
I don't know. I understand that you divided the -9 on both sides, and then you get 32.
Mm-hmm.
And then I don't know what to do after that.
Do you remember simplifying radicals last year in pre-algebra?
Maybe
Well, that's what we're doing is we're simplifying radicals. You're factoring that 32 to find perfect squares. So
okay, that makes sense. I think.
okay, we're finding perfect square. You're simplifying radicals. So you have to write the greatest common factors of 32. Maybe tomorrow in class for about 5 or 10 minutes, we need to just do a worksheet of simplifying radicals so that this will start to ignite, because this is part of the final, all of these ended up being perfect squares, unfortunately, which was sad, number 54 and 55. But it may not be like that on the final. You may have to simplify a radical. And yes, the quadratic formula on the final, you may have to simplify radicals. So
So
that's
like
a
on the
part of.
final, do we need to have the formula memorized, or is it going to
I
be?
will have the formula, but I need you all to be able to simplify a radical by then. I will give you the quadratic formula. I will give you the discriminant formula, but you will have to have memorized, you will have to be able to simplify a radical. So being able to figure out that the square root of 32 is 4 times root 2, or being able to figure out something like number 57, you would have to be able to do that. Okay?
It kind of makes sense.
Okay. Um, okay, and I had somebody ask a question about homework 10. Is that what we did over the weekend?
Yes, ma'am.
Yes, ma'am.
Okay. So this was all quadratic formula as well. Is that correct? Yes.
Yes, it was.
Okay. Let me try to, were there some that had to be, I want to look for some that have to be factored. Oh yeah. Number 7. Number 9. Yeah, some of the latter ones. So could I do those? Would that be okay with everybody if we worked on some of those? How many of you got it all done? And there's the little quadratic formula right up there on the right. All right, let me do number 7 with you. It's not in standard form. How many of you got this completely done? Is this worth me doing completely in Math Lab? Will this be a good review of the quadratic formula? Yes?
Yes, ma'am.
Okay. So we're going to add 2x to both sides. Then I'm going to subtract 3 from both sides. Okay, now it's in standard form. Now I'm going to identify A, B, and C. A is 1, B is 4, and C is -3. So now I'm going to plug that into the quadratic formula. So the opposite of 4 plus or minus the square root of 4 squared minus 4 times A times C, all over 2 times A. So x equals -4 plus or minus 16 times -4 times 1 is -4. -4 times 3 is -12. Oh, it's a -3. So it's a positive 12. I was like, that's the square root of 4. All right, so now I've got x equals -4 plus or minus the square root of 28 all over 2. So 28 factored
Mrs. Sparks,
looks like that.
thanks for the help.
Yes.
But I need to go.
Okay, baby. Have a good day.
Thank you.
-4 plus or minus, and then pairs make squares. So the 2's come out and the 7 stays in. All over 2. So that's going to -4 divided by 2, because is -2, plus or minus 2 divided by 2 is 1. So that's √7. So my final answer is -2 plus or minus √7. I'm not going to work through number 8. It's no solution. Because I would rather move to one where we really have to factor it. Because I only have about 5 more minutes that I can spend in Math Lab. So I want to move to something that is going to be more beneficial, where I'm really factoring and doing something to help you guys with simplifying radicals. So I'm going to number 8 is no solution. All right, so number 9, I'm going to subtract 3 from both sides. So 2x squared minus 8x minus 5 equals 0. Identify A, B, and C. So A is 2, B is -8, C is -5. So now I'm going to plug that into the quadratic formula. The opposite of -8, so the opposite of B, plus or minus the square root of -8 squared minus 4 times 2 times -5 all over 2 times 2. So x equals the opposite of -8, or -1 times 8 is 8, plus or minus the square root of 64. And then -4 times 2 is 8. 8 times -5 is a positive 40. All over 4. X equals 8 plus or minus 64 plus 40 is 104. All over 4. I'm going to factor 104. I'm going to do that over here. 52 times 2, 26 times 2, 13 times 2. So basically, underneath the radical, I have 13 times 2 times 2 times 2. That's these 3 2's. Pairs make squares. The only pair I have is this. So, which 2 times 2 is 4, and we know the square root of 4 is 2. So when I have a pair, I can bring it out. So it's 2. What's left inside? Someone tell me, what numbers are left inside? The radical.
13 and 2.
13 and 2. So 13 times 2 is 26, correct? So x equals 8 plus or minus 2 times √26 all over 4. Now 2 goes into 8, 2, and 4. So that reduces 8 divided by 4. You don't want to do that. We'll just do 2 into both. So x equals 4 plus or minus 2 goes into 2 one time. So that's going to be root 26 because it's 1 times root 26 all over 2. So that's your final answer because this is 4, this is 1, and this is 2. So this is your final answer for that one. How was that one? Good, bad, or
Not,
ugly?
not as bad.
I'm sorry?
Not as bad.
Not as bad. It's getting a little better. Praise
Yeah,
the
it's even better.
All right, good. Glad to hear that. Thank you, Mary Faith. Okay, so number 10, not in standard form. So I have to move the 5 over. So that's going to be 10x squared, negative 19 minus 5. That's going to be negative 24 equals 0. So I want to identify A, which is 10, B, which is 0, and C, which is negative 24. So now I'm going to plug that in. X equals the opposite of 10 plus or minus, no, I'm sorry, guys, the opposite of 0 plus or minus 0 squared minus 4 times 10 times negative 240, or 24, all over, multiplying in my head, 2 times 10. So x equals, the opposite of 0 is just 0, but we've got plus or minus, and then 0 squared is 0. Then we've got negative 4 times 10 is negative 40, and negative 40 times negative 24 is a positive 960 all over 20. So I'm going to factor 960. And I'm going to do my factor tree. I mean my birthday cake, just because this is a bigger one. The first thing we would want to do is find out if 960 is a perfect square, though. And it is not. You would get a decimal if you plugged in 960 and then you did second square root 960. So it is not a perfect square. So Sam reminded me of that good thing that we need to check every time. So underneath the radical, you would have 2 times 2 times 2 times 2 times 2 times 2 times 3 times 5. So what we're looking for, pairs make squares. So I have a pair of 2s. I have another pair of 2s and a third pair of 2s. So that means outside the radical, would have 2 times 2 times 2, identifying 1, 2 for each pair of 2s. There's a square for the square. And then inside the radical, I would have 3 and 5, 3 times 5. So I've got x equals 2 times 2 is 4, and 4 times 2 is 8. So plus or minus 8 times root 15 all over 20. So that equals 4 goes into both 8 and 20. So plus or minus 2 root 15 all over 5. So that's my final answer. How was that one?
Miss Sparks, can you scroll down a little bit? I can't see it.
I can.
Thank you.
I just wanted to make sure that y'all saw underneath the radical, that's what it looks like when you're breaking it into its greatest factors. And then when you pull them out, it looks like this. So for every pair, you get 1 on the outside because pair makes a square. So that's where my 8 comes from. All right, how'd y'all do? Any feedback?
Good.
All right.
All right. Okay. Y'all want me to do one more?
If you have time, yes, please.
Okay. All right, number 11. So not in standard form, so I have to get it there by subtracting 6x from both sides. So now I'm going to identify A, B, and C. And then I'm going to plug that in. The opposite of B is opposite of -6 plus or minus the square root of the square root of B squared minus 4 times A, which is 4, times C, which is -1, all over 2 times A. So the opposite of -6 is 6. And -6 squared is 36. -4 times 4 is -16. And -16 times -1 is a +16, all over 8. So x equals 6 plus or minus 52 all over 8. So I need to factor 52. So I've got a pair of 2's. So that equals 6 plus or minus 2 times the square root of 13. Because pairs make squares, so that gives me the 2 on the outside. Then this would remain inside the radical. So basically the square root of 52 looks like this, factored. So these two come out. They're a perfect square. They've served their time. So they come out on the outside, and that 13 stays inside the radical. It is not a perfect square, so it stays inside the radical jail. And now I have 6 plus or minus 2 times the square root of 13 over 8. So now what goes into 6, 2, and 8 to reduce, which that's 2. 2 goes into 6 3 times. 2 goes into 2 1 time. You don't have to write the 1, but you can. And 2 goes into 8 4 times. So my final answer is 3 plus or minus root 13 all over 4.
Thank you. That helped.
It did?
Yes, ma'am.
I hope so. Just remember, take your time, show all of your steps. Remember, every sign has a number and every number has a sign. Make sure you're identifying A, B, and C. I hope y'all have a good day.
You too. Thank you.
Uh-huh. Y'all take care.